Hi, hello, welcome back to the Math Club, Matthew, where you'll get content based on math for class 9th and 10th. In the previous video, we discussed about HCF, LCM, and the relation between them. If you have not checked that video yet, please do check it on our YouTube channel. In this video, we are going to discuss some of the very important questions based on the topics HCF, LCM, and the relation between them.
Now let's discuss some problems based on HCF and LCM. Let us see what kind of questions may be expected in your board exams from the chapter real numbers with the topic HCF and LCM. So here we have a question. 3 bells ringing at intervals 9, 12 and 15 minutes respectively. There are 3 bells which are ringing at the intervals of 9, 12 and 15 minutes respectively. If they start ringing together at 8 am, they ring together, then at what time will they next ring together? Question. I'll give you a minute, pause the video and try to understand the question by reading the question. Let me explain the question once again. There are 3 bells. There is one institution where there are 3 bells. There are 3 different bells. Bells A, B and C. This bell A will ring in every 9 minutes. This bell B will ring in every 12 minutes. This bell C will ring in every 15 minutes. Bell A will ring in every 9 minutes, bell B will ring in every 12 minutes and bell C will ring in every 15 minutes. So at 8 am in the morning, all these 3 bells rang at the same time. At 8 am we saw that A, B, C, these 3 bells rang at the same time. So then what happens to bell A? If it has already rung once in 8 am, so it will ring again at 8 am 9 minutes, 9 am. Then again it will ring at 8 am 18 minutes. Again it will ring at after 9 minutes after 8 am 27 minutes. Again it will ring after 8 am 36 minutes and so on. In the similar way, the bell B also. Bell B rang at 8 am already. All the 3 rang at 8 am. Again bell B will ring at 8 am 12 minutes. Again it will ring after the second time at 8 am 24 minutes. The next time it will ring at 8 am 36 minutes, etc. Now coming to bell C. Bell C also rang once at 8 am. So next time it will ring at 8 am 15 minutes. Next time it will ring at 8 am 30 minutes. Next time it will ring at 8 am 45 minutes. So it continues in the same cycle. Bell A will ring for every 9 minutes. Bell B will ring for every 12 minutes. Bell C will ring for every 15 minutes. So in future there will come a time where all the 3 bells will ring at a time once again. So we need to find out at what time will they ring once again. At the same time, what time is that we have to find out. So what can we do for that? So we have learned 2 methods. One is HCF and LCM. Okay, in such kind of questions you will be having that. So in this case we'll have to find the lowest common multiple, the least common multiple, that is LCM for this. Okay na? So I'll tell you at what time we'll have to use HCF, at what time you'll have to use LCM. I'll tell you that also. Before that, let us see how to find the LCM for these numbers. So if you face such kind of questions in MCQs, you can directly find the LCM and write the answer. If you are finding such kind of questions either in 2 mark, 3 mark or in competency based questions, you will have to write it stepwise. So let us write what is given in the question first. Given there are 3 bells which ring at 9 minutes, 12 minutes and 15 minutes respectively. So they start at 8 am. They rank together at 8 a.m. So we'll take the starting time to be 8 a.m. Okay. So to find the next time, okay, to find the next time when they will ring together, we'll have to find LCM of 9, 12 and 15. This is the notation we'll use to write LCM of any two numbers or any three numbers or so on. It is written like this: LCM bracket 9, 12, 15. That means LCM of 9, 12 and 15. Now let us find the LCM of 9, 12 and 15. Before that, we'll find the prime factorization of 9, 12 and 15. So we'll take the number 9. Let us prime factorize 9. So 9 can be written as 3 3s are 3 1s are. So 9 can be written as 3. Okay, I'll take 1 also. 1 into 3 into 3. Similarly, we'll factorize 12 also. 12 can be written as 2 6 are 2 3s are 3 1s are. So 12 can be written as 1 into 2 into 2 into 3, 1 into 2 into 2 into 3. Now here we have one more number, that is 15. Let us prime factorize 15 also. 15 can be written as 3 5s are 5 1s are. Okay, so 15 can be written as 1 into 3 into 5. So now how to find the LCM of these numbers? To find the LCM of, we have found the prime factorization of these. To find the LCM of 9, 12 and 15, now let us look at the common factors. Here 1 is a common factor. We know 1 is a common factor of all the numbers. So you need, even though you did not write this, it's not a big issue in this case. So let us, you can leave 1 because 1 multiplied by any number is the number itself. Now coming to the next numbers, this is 3, here we have a 3, here we have a 3. That means 3 is common in all the 3. We'll write all the 3 instead of all the 3 3s, we'll write 3 only once because 3 is common in all the 3. Okay, now here we have one more 3. Do we have any 3 here in any other two numbers? No. So that means this does not have any common factor. So let us leave it. So here we have 2. Do we have any common factor with 2? No. For this 2? No. Do we have any 5 as a factor of any other numbers? No. So we'll take, there is only one common factor, 3. So along with this we'll also multiply 3, 2, 2 and 5, the numbers which are left out. So I'll multiply 3, 2, 2 into 5. Are able to understand? So LCM of 9, 12 and 15 is 3 3s are 9, 9 2s are 18, 18 2s are 36, 36 5s are 180, 36 5s are 180. So we found the LCM of 9, 12 and 15 is 180. So that means all the three bells will again ring at the same time after 180 minutes. So we can write all the 3 bells. We can write all the 3 bells will again ring together after 180 minutes. So in the question they have also provided that they have already rung together at 8 a.m. Here 180 minutes, that means, that also means 3 hours. Yes or no? So after 3 hours again 180 minutes. See, 1 minute is equals to 60. 1 hour is equals to 60 minutes. That means 180 minutes is equals to 3 hours. So they have already rung together at 8 a.m. So after 3 hours again they will ring together. So after 9, 10 and 11 a.m. i.e. at 11 a.m. they ring together. 11 a.m. they ring together. So 11 a.m. or after 180 minutes was the required answer. Let us look at one more similar kind of question. So now let us look at one more kind of question. The question says 2 tankers contain 250 liters and 300 liters of milk respectively. Find the maximum capacity of the container that can measure either of the tankers exactly. So pause the video and try to understand the question. Take a minute to understand the question. Let me explain you the question once again. There are two tankers which contains 250 liters and 300 liters of capacity. Okay, there are two tankers whose capacity is 250 liters and 300 liters and they are completely filled with milks. So there are two tankers, tanker A and tanker B. The capacity of tanker A is 250 liters, capacity of the tanker B is 300 liters. Okay, so we have to find the maximum capacity of the container that can measure either of the tankers. There has to be one container that can exactly measure the quantity of milk in both the tankers. You know, whenever milk wala is giving milk, he'll have one container of different, he'll have a cylindrical container of different volumes, maybe 500 ml, 1 liter, etc. In the similar way, there is one container. In the similar way, there is a container of some quantity which can exactly measure both the tankers. If you put, like, if you take one 500 ml of container and pour all the milk in from this tanker A outside, it will exactly cover all the 250 liters of milk in tanker A. Similarly, it will also exactly cover all the 300 liters of milk in container B. So let us see what is the maximum capacity of such kind of vessels that we can have. Okay, so in such kind of cases we'll have to use HCF. Okay, so you can see the container, the volume of that container which is measuring these volumes must be smaller than this. That means we have to look at the HCF. If you think the answer which you are going to get will be larger than the values given to you, you should use LCM. If you think that the value of the answer that you are going to find will be smaller than the values given to you, you should use HCF. So in this case we'll use HCF. So let us write the answer in detail. Given there are two tankers of capacity 250 liters and 300 liters respectively. So we have to find the maximum capacity of the vessel, maximum capacity of the container that can measure 250 liters and 300 liters exactly. That means 250 liters. If you take, okay. So for this we'll find the HCF of it. So before finding the HCF, we need to find the prime factorization of these numbers. So let us find prime factorize 250. 250 can be written as 5 50s are 250, 5 10s are 50, 5 2s are 10, 2 1s are 250. So 250 can be written as 1 into 2 into 5 into 5 into 5. 1 into 2 into 5 into 5 into 5. Then in the similar way 300 I'll take 305, 60s are 305, 12s are 60, 6s are 12, 3s are 6, 3, 1s are 3. So 300 can be written as 1 into 2 into 2 into 3 into 5 into 5. So 300 can be written as 1 into 2 into 2 into 3 into 5 into 5. I'll make sure all the numbers are written correct, all the factors are written properly, the order does not matter. We have already studied it in fundamental theorem of arithmetic. So to find the HCF of 250 and 300, to find the HCF of 250 and 300, let us first look at the common factors only. So 1 is a common factor of all the numbers, so let it be. Now 2 is a common factor here, so we have 5 as common factor, we have 5 one more time as a common factor, so we are left with one more 5. Does this 5 has a pair over here? No. We have 2 and 3 left here. Does this 2 and 3 have a pair over here? No. That means the common factors we found as 1, 2, 5 and 5. So HCF of 250 and 300 is 1 into 2 into 5 into 5. Always remember, when you are finding LCM, first we'll write the common factors one time. Along with them, we'll also take the numbers which are left out. Whereas, whenever we are finding the HCF, we'll consider the common factors only and not any other unpaired numbers. So let us multiply. HCF of 250 and 300 is 2 5s are 10, 10 5s are 50, 50. So that means 50 liters is the capacity, maximum capacity of the container that can measure either of the tankers. So 50 liters is the maximum capacity of the container required. So this is how we'll solve this question. Now quickly try to solve the questions appearing on the screen now. Quickly pause the video and try to solve the questions appearing on the screen now, and come back, we'll discuss some more kinds of questions. Many students will have this doubt that when to use HCF and when to use LCM. At what kind of problems will we have to use HCF? What kind of problems will we have to use LCM? How will we get to know that? So let us get to know what to do. Previously we discussed these two questions. 2 milk tankers containing 250 liters and 300 liters of milk. Find the maximum capacity of the container which can measure both exactly. At this case we found the HCF of 250 and 300 and we found it to be 50 liters. Okay, then we discuss one more question. 3 bells ring at intervals of 9, 12 and 15 minutes respectively. If they start ringing together at 8 am, at what time will the next ring together? In this case we found LCM of 9, 12 and 15, that is 180 minutes. So why did I choose HCF over here and LCM over here? So let us see. Okay, now see here, there are 2 tankers, 250 liters and 300 liters. So there is one container smaller than that which can exactly measure all the milk from both the tankers. So here that container which can measure the quantity of the larger tankers will always be smaller than that. So if you think the answer which you are going to find will be smaller than the values given to you, you should use HCF. Okay. In this case, the bells are ringing simultaneous. The bells are ringing at the intervals of 9, 12 and 15 minutes. So once they have started at 8 am, next after some time in future, they'll again meet up and ring at the same time. That means the time will definitely increase. The time will never decrease lesser than this, yes or no? So no bells will ring in the time interval lesser than the given values. So they will always meet only after these given values. So this is the minimum which we can find. Okay, na, yes or no? So here the time which is given will obviously be of the value higher than 9, 12 and 15. So if you ever feel the answer which you are going to feel is higher than the given values, you should use LCM. Remember, if you ever feel that the answer which you are going to find is lesser than the given values, you should use HCF. And if you ever feel the answer which you are going to find out is higher than the given value, you should use LCM. So hope you are clear with it. So now quickly solve the questions that are given on the screen and come back, we'll discuss some more kinds of questions. One more kind of question that we might face in such kind of topics is this. Now read the question and try to understand it first. Given HCF of 200 and 180 is equals to 20, find their LCM. You can also find LCM by usual method, but in the previous video, we have learned one relation between HCF and LCM. This relation can also be used when HCF is known and the numbers are known, and the LCM can be calculated shortly. Okay, so look here. So what is given in the question? They have given HCF of 200 and 180 is 20. So there are two numbers A and B, 200 and 180. Their HCF is 20. We have to find the LCM of these numbers. Let us use the relation between HCF and LCM we have studied in the previous video. So we have studied that HCF of A comma B multiplied by LCM of A comma B is equals to product of A and B. So HCF of any two numbers multiplied by LCM of any two numbers will be equals to the product of those two numbers. So let us apply the same over here. So here the two numbers are 200 and 180. That means A is equals to 200, B is equals to 180. Okay, let us apply the same thing here. Given HCF is equals to 20, we'll apply in place of HCF of A and B, we can write 20 multiplied by LCM of A comma B. A comma B, A and B. What is the values of A and B? They are nothing but 200 and 180. So LCM of 200 and 180 is equals to product of both the numbers, that is 200 into 180. 200 into 180. So here we got linear equations. Let us try to solve this. If I send this 20 to the RHS, in the LHS we are having 20 into LCM of 200 and 180. In the RHS we are having 200 into 180. So if I send this 20 to the RHS, the 20 multiplied by LCM there becomes divided by 20. So let us write LCM of 200 and 180 is equals to, in the RHS we are having 200 into 180. I'll send the 20 towards that side. The multiplication over here will become divided by 20. So we'll get LCM of 200 and 180. So if you simplify this in the rough column, you'll get 200 into 180 divided by 20. 0 0 cancel, 2 1s are 2 10s are 180 into 10 is 1800. So 1800 is the LCM of 200 and 180. Now quickly note down this and try to solve the problems that are given in the screen now.